Hello, this is Mr. Zanaletto again. We're going to go ahead and do the second page of this week's scheduling worksheet. We have 2 of 3. This is the middle one. The diagraph of the following figures are respect graph. What is the vertices? That is, the vertices are members of group, and the arc XY would represent X respecting Y. So the more in degree you have, the more you're respected. The more out degree you have, the more you respect others. So if you choose one person to be the leader, who would you choose? You want someone that's well respected. So if you want someone that's well respected, A had 0 people respecting them. B had 1, 2, 3, 4 people respecting them. C had 2 people respecting them. D had 2 people respecting them, and E had 2 people respecting them. So obviously the most respected person is B. So I would say B, because all 4 other members respect B. And looking at those same values, who would be the worst choice to be a leader would be A. They'd have respect from nobody, because none of the 4 other members respect A. So that's how you would read that diagraph that's expressing the respect of others. However, the following figure is an example of a tournament. So now this is has a different meaning, but you have a graph here where each vertex represents a volleyball team, where XY represents the fact that X defeated Y. So when it's going towards that, the arrow is going to you, you've lost. The arrow is going away from you, you beat that other team. So which team won the tournament? Well, let's look. Who beat others? So A here has no wins. Nothing is leading out. B has 1, 2 wins. C has 1, 2 wins. D has 1, 2 wins. And E has 4 wins. So there you are. Which team won the tournament? Well, E has the most wins. E must have won the tournament. In fact, you could go further. Not only did they have the most wins, they beat all the other teams. They beat the other 4 teams. Who was last place? Again, poor A. A was last. They lost to the other 4 teams. Okay, so that leaves us through 5. The last problem on this page. Is draw a project diagraph for the following job. And in this case, I think the biggest, most important thing to do is, well, first of all, you have a start and a finish. So we're going to start. And then from there, I'm going to highlight this C, task C, and task G. Why do I highlight C and G? Because they don't have anything that needs to be done before they can get done. So we can say that C, which length of task is 5, and G, lack of the time of task is 2, are my two that have no prerequisites, nothing that has to be done before they have to be done. Now that C and G are being done, A needs C to be done. B needs C and D. Well, at the end of all this, I'm going to have C done, but not D, so I'm not going to highlight it. D has G needing to be done. E needs A and B done. A and B aren't even on the board. D is not on the board, so F can't get done, but G is done, so H can go. So these three that I highlighted in blue are where we are. Those can all be put on the board. C can be, after C is done, A can get done. When G is done, D can get done. And when G is done, H can get done. And D was going to take 2. H is going to take 2. And sometimes writing these in right now seems sort of somewhat silly because we really don't need that information at this time, but later on when we're filling in graphs next week, we will want that. So that's why I'm just getting the habit of writing down the task time. Now that I have went through those, let me go ahead. Now that I have C and D both on the board, I can lead them to B. Now once A, B's not on them, so I'm not going to do that. But after that, F, D can get, and D's done, so F can go. So I'm going to go ahead, B, C, and D lead to B. That's done. F, once F, D gets done, F can do. So I have now my two that are the third wave, is what I would call that. And now, finally, E can get put on the board because A and B are done. So if A and B can feed into E, when E is done, we'll go to the end. B went there. F didn't go anywhere, so it's going to go to the end. H, its outcome, doesn't go anywhere else, so it's going to go there. And that's it. There's my flow chart. My flow chart, I had yellow had no prerequisites. Blue had only yellow prerequisites. Green actually only had yellow and blue prerequisites. And orange had a green prerequisite. So those were the only way that we could go through that. Okay, one last question was with respect graphs, which I think is a little easier. This one you have to use some logic, and that is something I'm going to ask you to do. So you should be able to look at a table and make the graph. You should be able to look at a graph and make a table. Okay. Now the last question that's here is a respect graph, and we have A, B, C, D, and E. So we have A, B, C, D, and E. And just to try to keep these sort of clear, A respects E, A respects B, E respects B, D respects B, and C respects B. That's all of those. Now I'm going to go ahead and switch colors just to try to keep things a little more organized, but B respects D, E respects C, D respects E, and C respects D, and B respects C. Now, that's all they're asking you to do. I am going to go ahead and take a second. A has no respect from anybody else. B has respect from 4 others. C has respect from 2 others. D has respect from 2 others. And E has respect from 2 others. Now when I look at that, it looks exactly like the one at the top of the page. And it helps to show how much they respected each other, because I can see then that those numbers start lining up as same as they were at the top of the page, and then I look a little harder, and sure enough, this describes the graph they gave you at the top of the page. So thank you. That's it for the second page, and we will go ahead and have a third video here in a few minutes. That will be the third page. Thank you.